Awesome. And with that, we can get started. Thanks everybody for joining. Once again, my name is Adam Noonan. I'll be hosting today's session. This is our weekly Kafka live stream. If this is your first time joining, we do 30 minutes every Thursday, just giving tips and tricks as well as general trends we're seeing in the event-driven architecture ecosystem, as well as just advice on when you're working with Apache Kafka. It can get pretty daunting with this new event-driven paradigm. So we offer these sessions for our customers, but also just the wider Apache Kafka ecosystem for people that are navigating the new event-driven realm, trying to make things as simple as possible so that your company and organization can be as profitable as possible. Today, we're going to be talking about managing Kafka consumer offsets, what that involves architecturally, how Kafka handles scalability and parallelization, and how that affects an application that's reading data from an Apache Kafka event log. Once again, we do this every week. So that's 11 a.m. Eastern Time, 5 p.m. CET. This week, again, we're talking about Kafka consumer offsets. Next week, we'll be talking about security operations with Apache Kafka, and specifically using an external secrets provider for Kafka Connect. Tends to be a hot button topic, especially with companies just getting started with Kafka Connect and their CI/CD integrations specifically for Kafka Connect. So that will definitely be a fruitful conversation for secure connections into and out of Apache Kafka. We'll follow that up with data masking and sensitive data discovery. So when you're working in production with private information, could be financial, health-based, anything that you want a developer to be able to work on an application that provides value to your organization, but not actually be exposed to sensitive information. So definitely keeping with the security theme going forward next couple weeks. We're going to keep talking. We've got a whiteboard session, not as many slides a day. We're going to try to keep it more of an open discussion. So if you do have any questions, please feel free to raise a hand, come off mute, let us know what your thoughts are and anything that we can clarify as well. Definitely here for you and any questions and information you're looking to gain from these sessions. Additionally, we're always revamping our agenda. Since we do this weekly, we're always looking for additional topics. So if anything comes to mind, something you're working on that you'd like some advice on or general background information for, definitely give us a shout and we can add that topic to our agenda. Once again, I'm Adam Noonan. Joining us today is our broader ecosystem development engineering team, especially my friend Matthias Oliveira. He's our expert professional services consultant, and he'll be helping us discuss the Apache Kafka architecture, as well as how to handle Kafka consumer offsets, specifically when things go wrong, what you need to know, and how to reduce your mean time to resolution. And who are we? We are Lenses. We provide the ideal developer experience for Apache Kafka. So no matter your flavor of Kafka, wherever it's hosted, we can get your developers off of the command line interface and an actual user interface with governance structure, enterprise grade, authentication and authorization, all the good security features to make sure that your environment is safe and secure, along with all the development experience features as well to ensure that your developers are reducing that time to market for those new features and applications in real-time data. Today, oh, and definitely be sure to join our community. We'll get more to that later, though. I'm going to set Matthias up for what we're talking about today, which is managing Kafka consumer offsets. Matthias, if you'd like to take over the screen, I think we have a bit of a 101 to go over the architecture so that we know what we're all talking about when we say a topic, a partition, a consumer task.
Okay, you hear me now?
There you go.
Yeah, great. First of all, we missed you in the last session, so I must say that. You are the host. Guilherme is amazing, he's a great host, but you are the host of the show, so we miss you. So let's try to do this as we talk, and the most of thing, guys, is for you guys to participate on things. We're gonna try to bring value, to give knowledge of you, of Kafka and how you use Lenses to reduce the effort on that. But the most of things, if you have, Adam say, if you have a subject or something that you want to know, to learn, just send to us. We are more than welcome to do this. So I think everybody's seeing my screen. If not, let me know, but I think it's good. Yeah, thanks, Adam, for the thumbs up. So before we start to talk about offsets, we should I think 3 steps behind. And let's go back 3 steps. Let's first understand what is a topic. Topic was where the data, logical data, is stored in Apache Kafka. So it's a key value organization that Apache Kafka has. There's a topic is similar to a table, I can say, per se. But again, it's a logical part. And then I have my key and I have the message itself. But I put these numbers. These numbers are actually the partitions. The data is breaking partitions to scale. Bear with me. I know if you have beginnings with Kafka, don't worry, we're going to explain how it works. But the whole idea is to break, to be more easy to scale your application, to read fast and to produce fast data. So far, when we break this, imagine I have in this case, 5 partitions, all data scattered, how I can position, how can I found, how can I look for the data that I want, how I can know when I have a problem with my downstream application, how can I go? And this comes to the offset. The whole idea of the offset is I know when and where the data is. So the data is a new data, is a data that has been arrived now or has been old data. All of things for the consumer wise is not about the offset. So the whole idea here is to do something like this. I'm a Python guy.
Before we go on, I think maybe a question just to clarify
Yeah,
a
great.
thing. So if I can summarize, maybe correct me if I'm wrong. So we've got our topic, essentially a database table would be an appropriate analogy. That's a store of similar information. Within that, we have our rows, which are now event messages. So we have our event log of specific messages, all within that same topic. But instead of just a single store, we have that sharded into different parallel event logs, which are partitions, correct?
Exactly like that, man.
So here's a question for you,
Nailed.
Matthias. What would determine which partition a message goes to within a topic?
Amazing. That's amazing question. Depends of how you structurize your message. If you send a key, the first time it's right is going to be always the same partition for that specific key. So always the time I can send message without key, and like if I want, I can say no key. I can set only the value. But in this case, it's going to be round robin. The first one to respond to the first one to receive the data. If I want to, I want to do a specific partition. The first one I send the key is the B1. For example, if I send the key 1, let's put like this. If I put the key 1 in the partition 2, for example, every time that a message happens with the key 1 is going straight to the partition 1.
Perfect. So Kafka will hash that key value, and whatever has that identical hash will go to that partition. Fantastic.
Exactly like that, my friend. Just like that. And it's more like partition strategy. Most of the people doesn't know that, but the whole idea is if you want to have some fast application to read a specific partition, you can push all the keys to a specific to go to a specific partition. So it's more efficient.
So that's how we parallelize the write to Kafka. How about the consumption of data from a Kafka topic?
Yeah, let's see now how this works. So the whole idea is, I think that's the beauty of Kafka, how he was built, in my opinion. You have the producer who's producing data into a topic, sending data. What happened is the topic is breaking partitions of sets, like I say. So I have a Java application that look for their partition, spin up inside of Kafka a consumer group. That's I love how they build this. So the idea of consumer group, and then say, okay, how many threads that I have open for this application? For example, we're gonna see 3 threads open. So in this case, each thread is gonna read 1 partition, for example, based on how many partitions do I have. If I have, in this case, I have 8. If I have 3, I'm gonna have 2 for each, and 1 is gonna be scrambled for one. We respond faster. But the whole idea is I know the exact position if my application fails or my application stops. So every time that I go into my topic, I read for the consumer offset, say, okay, which is the offset that I stop as my consumer group? Oh, you stop on the consumer 5. The 5 partition 7 offset 5 is the last message that you read. So 6 and go on and go back to the consumer. So Kafka has this way to manage who is consuming, and I'm going to show you how we can spin up and how this works. So the whole idea is you have a question? Please send me a question. So far, so good. Let me know if you have any questions. So the whole idea is, for example, I have this application with 3 threads and three partitions. What is happening is this thread is reading the offset 2, this thread is reading the offset 5, and this thread is in the partition 2 on 1, start to consume. Again, it seems complicated, but when we go to Lenses, you're going to see how easy it is to manage this kind of stuff. Initially, is because I think Kafka is complex in per se, but the whole idea is for us to make more easy for you guys to understand how complex is the whole process and how you can manage. But again, this is Kafka. This is how it goes. Adam, you want to show them how Lenses do it?
Yeah, absolutely. So we've talked about topics can be akin to a table. Within that topic, you have your partition. Your ordering is guaranteed within a partition where you have your offset, which would be the number of messages as it is in that order of partitions. That's also how you parallelize both production and consumption of data. So for maximum throughput for a topic with 3 partitions, you would have a consumer group with 3 instances consuming from one-to-one relationship for each partition, and you know exactly where that consumer is within that partition's ordering by its consumer group offset. So let's talk about when things go wrong. That's everything how it works architecturally when it's going right. But our example scenario here, we're using lenses in our topology feature, which is a great way to build an intuitive understanding of your data flows into and out of Kafka. And we have our position reports topic here. This topic contains information, geolocations around shipping vessels, sea ships that are containing cargo. So very important information. We have our microservice that is registered with lenses to produce information here. In our example scenario today, and obviously a lot of downstream consumers, so it is a very much a critical production application. If there's any downtime, that equals dollars lost. So mean time to resolution is of utmost importance here. In our example scenario here today, we're going to hypothesize and theorize that fleet positions are producing microservice has been corrupted. So a developer, maybe a junior dev, pushed a change to a repo. We've deployed that change to this application, and it's still producing data, but it's actually corrupted. Either the data is not clean, and we're seeing an improper state downstream in our external store that we're syncing to, or the message itself is actually corrupted and these downstream applications are actually breaking. They're unable to even consume the message. Either way, a big problem that needs to be addressed as soon as possible. And as you can see, we've got the warning, it's throwing errors already. So the first thing I would do as a developer SRE that was pinged would be to take a look at this topic and get an understanding of the actual data. And I can jump straight to this topic. I can see specific message fields, and it's very easy to view them as a table as well to see trends and get a feel for what that data should look like. I can also jump to partitions, which is actually exactly what we were just talking about. This topic has 15 partitions, and I can see those heat mapped here to understand which partition is containing the most amount of data and how effective my partitioning strategy is. But I'm a developer, things are wrong, everything's on fire, and I've got to find out exactly when this producer started having a problem, and if it stopped having a problem, when it stopped. In the Kafka CLI, this can take a while. You have to query, run a CLI consumer, understand the data, view it in your command line interface, or sync to an external store and replicate that data, pay for that network cost and those storage costs, additional time and money while we're already losing money with our application being down. Lenses makes that easy because we have our SQL Studio, which makes it very nice and easy to query information, either based on the actual message data itself in a very familiar SQL syntax, or you can query based on Kafka metadata. For instance, in our fleet producing application, we can say that the developer deployed the change, the corrupted data was produced within a specific time period. We're going to call this yesterday. Then we can run this query here, and we're actually querying Kafka itself without touching the command line interface. So someone who's not a Java developer doesn't have a lot of experience with Kafka can easily do and start to pinpoint the problem. So this data is obviously clean and fine, but in our scenario, this is where we'd see, okay, right about this timestamp, I can see that data started going wrong, and later that data started going right. In our scenario here, we're talking about a producing application that's been corrupted, and it's producing data to each of the partitions for a significant period of time that we need to skip over. And to do that, we need to manage the Kafka consumer offsets. And to manage those in aggregate and change all of those and make sure that we're getting this application back online as soon as possible, we've actually released a new feature for managing Kafka consumer offsets across all partitions at once. Matthias, are you ready to demo our new feature for managing Kafka consumer offsets in aggregate?
Yeah, of course. And again, guys, this is a test environment. Problems can happen. Don't worry, bear with me. I'm gonna try to show you. And the whole idea of this new feature is, okay, now I have to change almost all the offsets. I have to change more information. I have to replay the entire topic, and then I have to change my application for that. That's how lenses come to play. So the whole idea is you have this tab. Let's go back to this tab. You click in consumers. You have all the consumers groups in your cluster. That's the view that you already have. And then you say, okay, now I have to change this one, for example. Initially, you can change one by one if you want, but that case, I want to replay all of them. So we have this nice button called actions, change multiple offsets. I'm gonna make a zoom in for you guys to see better. And then voila, I have this set for the start, set for the end, or specific date. Like Adam showed, I can query in the SQL Studio and say, okay, now I want you to pick the offsets from this specific date forward. Or in this case, what I'm gonna do is, if you see here, just for us to see, is different the start offset from my current offset. So I'm gonna give, let's start, as you guys to see. And then what's gonna happen is, let's see, okay. And now when my application starts to run, is not active of consumer group. When he starts to run, he's gonna start for the start offset of everything. So you're gonna start of the offset, and gonna read everything, replay the entire topic. Imagine if I have to do this by hand, like one by one, or I have to change my application to earliest. Everything is here to help you out to do this kind of stuff. So I can do even better. I can go and have a question.
I can wait. I can wait. I'm sitting on my hand, but go ahead.
I want your question. You can say.
I just wanted to say it's really cool because I'm noticing now for the first time that at each offset, it looks like it's a clickable link. And I know there was a big customer that requested this for the specific scenario of, hey, we have a lot of war rooms. We'll have 20 people in a room, and we need to understand what's causing the lag, where this consumer stopped at. And instead of, they complained that they had to copy that offset and then go to a different page in Lenses to view that actual message. But if you could just quickly click on a current offset, this has been a widely requested feature for them to quickly, just to the left of that, where the actual number is for a particular instance.
Okay,
Awesome.
just
Yeah, that's super cool.
yeah.
And we can see that specific offset for that partition. Nice. Oh, and it gives you a little bit of a range too. So that not only that offset, but the following one as well. So you get a quick comparison too. So if that was a bad message that was hanging up that consumer task, you can quickly view that and address the problem, either skip that offset or change it. But cool. Sorry to interrupt.
No, please interrupt. That's the whole idea is to be interactive. Thanks for the insights. And what I can do here, let's go back to ours, and then I can go and say, okay, I want to delete the entire offset. I can go and say delete. I can go a specific topic if I want, because one consumer can read multiple topics. I can say, okay, I want to delete a specific topic with this consumer, or I can delete all the consumers. Before I show that, I can go here and go delete consumer group. I can come here and say, okay, I don't want this consumer group anymore on my environment. I can go and delete this consumer group. So that's one of the features that we're gonna come up with the next versions. I think for the demonstration, I can stop here. If you have any questions, I think it's good for us to have 5 minutes to make some questions. And Adam, I think it's back to you, my friend.
Thank you so much, Matthias. Yeah, 30 minutes can be a bit quick. Sometimes these sessions are a little information dense with a little bit of bouncing around between 101 and how you use it in practice. So, quick 5 minutes. Feel free to ask questions about what we presented today or anything you're working on yourselves. I think, Geetha, you have a question. If you'd like to come online, we'd love to hear about what you're looking for.
Yeah, hi. Yeah, I was checking for one of the like we one application it is filling up more space on in Kafka topics. So I don't see anything in lenses to check where and which mount point for a pod or this topic is filling up. So I have to go to again physically to the pod and check for df minus h so that I can see the mount point filling. But is there any way we can check it in lenses, either with the SQL query or on the portal?
So how much space a specific topic is taking up?
Yeah, for example, let's say in one of the mount point, it is filling up 80% or 90%. So I am not able to see in lenses. Only thing is I have to go into a pod and check
As a percentage of the underlying storage available for that broker or for the cluster?
for the cluster on mount point.
Got you. And when you say mount point, could you provide some more clarity there?
If I log into that one of the pod like Kafka data host, and then I'll be checking df minus h so that I can see the all the mount points and the usage of those mount points, right? So is there any way I can check in lenses that okay, this topic is consuming this much of space and this is the pod name and this is the mount point where it is filling up?
Gotcha. So topic space as it relates to percentage wise of available storage in relation to a specific mount point. We do have a few metrics available for the underlying storage. Obviously, right here, you can see the exact amount of information and data stored within a topic itself. As far as CPU and storage system load, we have these high-level metrics, but the intention for Lens is really to be an operational tool. So if you're working with Apache Kafka, developing new applications or troubleshooting data flows, that's where we provide observability information as it relates to new applications, new features, and troubleshooting when things go wrong. For our paying customers, we do provide a Grafana dashboard that gives some more low-level actual observability metrics that you'd be looking for in relation to CPU usage and data storage. I do know that we have some features planned related to data consumption and team usage too, compared to as a ratio of available resources. That's been widely requested specifically by customers that are in a multi-tenant offering where they've got different internal or external customers writing to and reading from their Kafka that they're offering up as a service, which will enable them to then charge back to their own customers. So that's definitely in the roadmap and something related. But if you have a Lenses license as well, would definitely encourage you to check out the Grafana dashboards that we make available. We had one developer actually spend quite a bit of time on those, and I've had some really great feedback about what we have there. So I'd suggest checking that out in the short term, and then on the long term, stay tuned for what we have planned in the future with the product. Feel free to join our Slack community. You can interface with our entire team there, as well as our broader ecosystem and community too. So people that are using Lenses every day, or people that are just working with Apache Kafka and event-driven architecture. And Sandra put a link in the chat. Tune in next week as well, where we'll be talking about security operations with Apache Kafka and Kafka Connect, how to use an external secrets provider.